Okay, let's dive into this. Welcome to today's Explainer, where we're heading to one of the coldest, darkest, and honestly, most extreme environments on our entire planet, the Antarctic Ocean. I want you to imagine, just for a second, plunging your head beneath that thick, freezing ice into pitch-black waters. What do you think you'd actually find down there? Logically, our brains kind of tell us that in a place with sub-zero temperatures, where sunlight barely even makes a dent, and food is incredibly scarce, life should be really struggling, right? I mean, basic biological reasoning dictates that animals living in those conditions should shrink, to conserve their precious energy. You'd totally expect to find just tiny little fish or microscopic organisms barely holding on in the freezing depths. But the reality of the Antarctic Ocean completely shatters that logic.
Now, what's really interesting about this slide is the stark contrast between what we'd expect and the absolute nightmare fuel actually lurking down there. Instead of those microscopic survivors, the depths are prowled by massive, terrifying creatures. We are talking about marine animals that have mutated into absolute giants, completely breaking the standard rules of biological evolution that govern the rest of the planet.
Scientists actually have a name for this bizarre phenomenon. They call it polar gigantism. It's this wild, localized evolutionary anomaly where marine species living in extremely cold polar regions just massively outgrow their relatives living in warmer waters across the globe. So a creature that might be tiny in a tropical coral reef, it transforms into an absolute leviathan when placed in the freezing waters of the Antarctic. But how? What exactly triggers this bizarre transformation?
Well, the answer isn't some magical abundant food source. It's actually hidden in the water itself. It all comes down to oxygen. Scientifically speaking, freezing cold water can hold drastically higher levels of dissolved oxygen compared to warm water. In warm oceans, oxygen levels act as a natural ceiling. As a cold-blooded animal grows, its cells demand more and more oxygen, and eventually the warm water just can't provide enough, which naturally caps the animal's size. But in the Antarctic, where temperatures hover below zero, the water is supersaturated with oxygen. That biological growth limit, it's just completely removed. It's essentially an evolutionary cheat code that's allowed cellular growth to just run wild over millions of years. To truly grasp the sheer scale of this, we've got to look at the colossal squid. Now, you might have heard of the giant squid, which grows massive due to a totally different phenomenon called deep-sea gigantism, which is driven by immense oceanic pressure. But the colossal squid is a true scientific marvel because it experiences this incredibly rare double crossover. Basically, it lives deep enough to experience deep-sea gigantism, but it also lives in the Antarctic, subjecting it to polar gigantism at the same time. The result? The largest invertebrate on planet Earth.
While a colossal squid might share a similar length to a typical giant squid, it is incredibly dense. We're talking a staggering weight of up to 16 tons. To put that into perspective, that's twice as heavy as its giant cousin. And what's even more fascinating is its evolutionary adaptation. Its ancestors were these small, transparent glass squids. But in the Antarctic, being transparent is totally useless. So thanks to polar gigantism, it evolved this thick red muscle tissue. Since red light doesn't penetrate the deep ocean, the bioluminescent light from its prey won't reflect off its skin. It's literally a 16-ton monster that its prey can't even see coming. No way, right?
Okay, if massive squids weren't enough, let's talk about spiders. If you're the kind of person who gets terrified by the tiny 1 to 2 centimeter spiders you occasionally find in your house, the Antarctic sea spider is going to be pure nightmare fuel for you. Because of that boundless oxygen in the water, these creatures expand to over 2 feet wide. 2 feet! And get this, they don't even have traditional lungs. They literally absorb the abundant oceanic oxygen directly through the surface area of their massive, elongated legs. And this brilliantly illustrates the terrifying reality of their ecosystem. These giant spiders don't scurry around picking fights. They are silent, highly methodical hunters. They stalk the ocean floor on those massive legs, use a specialized tube-like mouth to pierce their prey, and quite literally suck the insides out of their victims like a milkshake. I mean, it is brutal, it looks entirely alien, and it's completely enabled by that extreme cold.
Now let's move on to a creature we normally associate with, gentle, sunny tide pools, the starfish. A standard starfish has 5 arms and mostly just chills out, feeding on small clams or oysters. But in the Antarctic, polar gigantism mutates them into something totally unrecognizable. These starfish can develop up to 50 arms, and they definitely don't just eat clams. These 50-armed giants are vicious cannibals that actively hunt down and devour other starfish.
And because all their biological processes are altered by this freezing, oxygen-rich environment, their lifespans are drastically extended. While a typical warm-water starfish might live for a brief, maybe 5 years, these giant Antarctic cannibals can live for well over 40 years. They just dominate the seafloor for decades, silently ruling over their frozen domain.
But perhaps the most mind-blowing creation of polar gigantism, for sure, is the lion's mane jellyfish. We all know the blue whale is the heaviest animal on the planet, right? But if we are talking strictly about length, the lion's mane jellyfish actually beats the blue whale. It legitimately holds the title for the longest animal on Earth, and it is a direct product of this extreme oxygen-rich environment, dwarfing its warm-water jellyfish cousins in ways that are honestly hard to even comprehend.
Now you might be wondering, wait, what about penguins or polar bears? Are they giants because of this oxygen thing too? It's a great question, but the science actually diverges here. Polar gigantism specifically applies to cold-blooded creatures that draw their oxygen directly from the water. Mammals and birds, like polar bears and penguins, are warm-blooded. Their large size is dictated by something called Bergmann's rule. Basically, they're large because a bigger body mass retains internal heat way better, keeping them from freezing to death. They don't have the luxury of unlimited growth because in this desolate environment, they still have to hunt down enough food to fuel that massive internal furnace.
Interestingly enough, evolution always has a backup plan. In very rare cases in the Antarctic, we see the exact opposite effect taking place: polar dwarfism. When food is exceptionally scarce, certain creatures like snailfish and icefish actually shrink compared to their warm water relatives. In a literal life or death struggle, becoming smaller means they need less food. That allows them to reach maturity and reproduce much faster just to save their species. It just goes to show you the absolute extreme adaptability of life.
But whether they are giants or dwarfs, the sheer cold of the Antarctic has another really profound effect. It basically slows down time. Because the environment has been incredibly stable for millions of years, the evolutionary process happens in extreme slow motion. Generations take decades to turn over. The giant creatures we're looking at today are practically living fossils, existing exactly as they did before humans even walked the Earth.
So the crucial point is this: the very stability that allowed these incredible monsters to evolve over millions of years is now their greatest fatal weakness. Their entire existence relies on a delicate balance of extreme cold and supersaturated oxygen. As climate change rapidly warms our global oceans, the water physically loses its ability to hold that vast amount of oxygen, and as the oxygen drops, these massive creatures literally cannot sustain their giant bodies. They face the horrifying reality of suffocating from the inside out. It's a deeply tragic paradox. Despite their absolutely terrifying appearances, a colossal squid has never killed a human being. They're just harmless giants, this precious ancient heritage of our planet. Yet human-driven warming is already leaving a mark. Scientists have noted that the giant sea spiders we talked about are already beginning to shrink in size as the waters warm. We are actively threatening to wipe these living fossils out completely before we even fully understand them. Which leaves us with a really profound thought to wrap up on. For millions of years, the absolute harshest, freezing oceans didn't destroy life. They actually amplified it, creating these magnificent giants. So we have to ask ourselves, if the freezing cold allowed them to conquer the depths, what will our human-driven warmth ultimately do to these ancient giants? Thank you so much for joining this explainer. Keep questioning the world around you, and I'll catch you in the next one.